Okay, now that we have looked at the finding vertical asymptotes and horizontal asymptotes for rational functions, we want to put all this together and analyze rational functions and look at their graphs. So how do we go about doing that? Here's the general guidelines I have. First of all, we want to help us, if we can, factor the numerator and denominator. If you remember rational functions, there's one polynomial in the top divided by a polynomial in the denominator. We want to factor each of those, and that will help us to find the zeros of each of those polynomials, and those zeros are very important. For instance, in the first step, finding the domain and restricted values, the restricted values are the values that make the denominator 0, right? When we're dividing by 0, those are restricted values. And we do not want to include those values in the domain. So again, the domain for rational functions are all real numbers except those restricted values, those values that make the denominator 0. We can then find the y-intercept, which is pretty simple for any function, rational function, polynomial function, linear function. We simply let x be equal to 0 and find the value of y. What's the output? Now there is one exception with rational functions. It is possible that x equals 0 is a restricted value. In that case, what's happening? We can either have a vertical asymptote or we can have a hole in the graph. And so it is possible for rational functions not to have a y-intercept. Next, we're going to find the real zeros, or the X-intercepts for the graph. And the way we do that is we find the zeros of the rational function by finding the real numbers that make the numerator 0, the top 0, but the denominator not 0. Okay, so we already know if the denominator is 0, values of x that make the denominator 0 are restricted values. Those are values not in the domain of the function. So to find the real zeros, we want the top to be 0 and the bottom to be not 0. And those will be X-intercepts, the real zeros. We're talking about real numbers, not the non-real or imaginary numbers or complex numbers that may be zeros, just the real zeros. Then we're going to find any vertical asymptotes, and we talked about that in the first video on this topic. And then the horizontal asymptotes, which we talked about in the second video. And one thing I like to do too is when I find the horizontal asymptote, if there is one, I want to determine if the function ever touches or crosses the horizontal asymptote. And I'll show you how we can do that algebraically. And then when we sketch the graph, what we're going to do to help us is we simply plot at least one point in each interval between and beyond the zeros and any vertical asymptotes, or if we have holes in the graph. And then we get a rough sketch. When we do sketch the graph, we do want to draw any vertical or horizontal asymptotes with dashed lines. I'm going to use dashed lines to do that, and I'll show you how to do that using a straight edge. Okay, let's look at our first example here. Now, on the test, instead of just giving you the function and say go at it, I'm going to guide you through all those steps. I'm going to help you out on that. And so there's a series of questions that I have. And of course, the first thing you want to do, the first step was to factor the numerator and denominator. In this case, both the numerator and denominator are just degree 1 polynomials or linear functions, and there's nothing really we can factor out of those. So the first question then is, what's the domain for this function? And to find the domain, remember that we need to find the restricted values, the values of x that make the denominator 0. And so I'm going to start with just saying the domain will be all real numbers such that the denominator is not equal to 0. Well, if 2x plus 3 is not equal to 0, then 2x cannot equal what? Negative 3. And therefore, x cannot equal what value? Negative 3/2. And so what's the domain? The domain we can write this way in set builder notation. It's the set of all x such that, if you remember, vertical bar in mathematics means such that what? Such that x is not equal to negative 3/2. Okay, that's one way we can say it. Or we can say it using interval notation. That would be everything excluding negative 3/2. So from negative infinity to negative 3/2, parentheses, we don't want to include it, union or negative 3/2 onto positive infinity. So either of these will work, or, if you just write in words, all real numbers except negative 3/2. Okay, so there's the domain. Now, let's find the y-intercept. Well, y-intercept again is easy. We simply plug in x equals 0 into the function, and what do we get out? So I'm going to plug in x equals 0 here, get 1 minus 2 times 0 over 2 times 0 plus 3, and that comes out to be 1/3. So you can say the y-intercept is 1/3. I usually say it is 0, 1/3, right? It's a point on the y-axis. So there's our y-intercept. Now, we want to find any x-intercepts. So where are we going to have x-intercepts? It's when the function r of x is 0. It's the zeros of this function. When is this going to be 0? Okay. Please don't say it's going to be 0 when x is equal to negative 3/2. If the denominator is 0, we get an undefined expression. Division by 0 is undefined. So how am I going to get an output of 0? The top has to be 0 and the bottom not 0. So when is the top 0? When is 1 minus 2x equal to 0? Can you solve that equation? I hope you can. It should be when x is 1/2. Right? And notice that's not the restricted value, and that's good. So the numerator will be 0 when x is 1/2, and the denominator will not be 0. That means r of x will be 0 for that value. And so the x-intercept, though, is what? 1/2, 0. That's our x-intercept. 1 x-intercept. Vertical asymptotes. Do we have any vertical asymptotes? And we're going to write their equation. Well, remember, the only possibility for a vertical asymptote is where we have a restricted value. The only question is it a vertical asymptote or is there a hole in the graph? So the restricted value is negative 3/2. So again, if I look at r of negative 3/2, what do I get as an output? Of course, we know the denominator is 0. Again, this is not going to be a real number. This is undefined. But the top would be what? If I plug in 1 minus 2 negative 3/2, 2 times a negative 3/2, the 2 cancel, I get negative 3. 1 minus a negative 3 is 1 plus 3. I get 4 divided by 0. I'll put that in quotes again. That's not a real number. I can't divide by 0. But what this form is telling me is that I have a vertical asymptote at negative 3/2. When would I have a hole in the graph? How would I know if I have a hole in the graph at negative 3/2? That's when you get 0 over 0. If the top and bottom are both 0, meaning we have the same factor in the numerator and denominator, then it's a hole in the graph. But this tells me that we have a vertical asymptote at negative 3/2. How do I write the equation? The equation is x equal negative 3/2. Remember, vertical lines are always x equal. So vertical asymptotes will always have x equal. Don't write this, negative 3/2. That is incorrect. Negative 3/2 is a number. It is not a vertical line. Vertical asymptote is a vertical line. X equal negative 3/2. Very important that you write out the equation. I'm going to emphasize that on the test. Make sure you do that. And that's to differentiate between vertical and horizontal asymptotes. Now, does the graph have a horizontal asymptote? Well, remember the degree of the top is 1, degree of the bottom is 1. Since the degree of the top and bottom are the same, we do have a horizontal asymptote. So yes, we do. And what is it? It's the ratio of the leading term coefficients. What's the leading term coefficient up top? It's 1 minus 2x, or 1 plus a negative 2x. It's negative 2. This is the leading term, this negative 2x up top. So it's negative 2 is the leading term up top. In the bottom, it's 2x is the leading term, and so the leading term coefficient is 2. What's negative 2 divided by 2? negative 1. There's the equation. Notice the equation. Right? The equation for a horizontal asymptote is always y equal the number. So the horizontal asymptote is not negative 1. That is incorrect. Negative 1 is number. It's y equal negative 1. Okay, so that's the basic information, and now we transition to beginning to sketch the graph. And one question I like to ask, just is does the graph cross or touch its horizontal asymptote? If so, at what point? So, of course, this is only valid, or the only time we would want to answer this if indeed there is a horizontal asymptote, which there is, right? Y equal negative 1. So the output y is negative 1. So the question is, does the function r of x ever equal negative 1? Does it ever reach that height of negative 1? That's the question. Well, we go back to the original function r of x. I'm going to go back to the original function up here and just set that equal to negative 1. And I'm going to solve that equation. I'm going to solve that equation. Does anyone remember how to solve such an equation? It's a rational equation. We want to multiply both sides by the least common denominator, which is just what? 2x plus 3. So I multiply both sides by 2x plus 3, and I get 1 minus 2x equals negative 1 times 2x plus 3. Or distributing this negative 1 through, I get 1 minus 2x equals negative 2x minus 3. Right? Negative 2x minus 3. Now, notice if I add 2x to both sides of the equation, what happens? Both these 2x's disappear, and I'm just left with 1 over here equaling what? Negative 3. 1 equal negative 3? That doesn't seem right. Have we made a mistake in this process? No. What happens when you're solving an equation and you get a statement like this, which is obviously false, or what we call a contradiction? It simply means there is no value of x that I can find such that this is equal to negative 1. There is no solution. There is no solution to this equation. No solution, right? Because clearly 1 does not equal negative 3. So what's that mean? Does r of x equal negative 1? Answer? No. And so, does the graph of r of x cross or touch its horizontal asymptote? No. So in this case, we don't. Okay. Let's take a look now at sketching the graph. And what we're going to do is we're going to plot the things we know. So the first thing we're going to do is we're going to plot our y-intercept, our x-intercept. We're going to draw our vertical asymptote and our horizontal asymptote. If I had a point here, if I did touch the horizontal asymptote, I can include that point. Okay. So let's do this. I'm going to plot the points that I know. I know 0, 1/3. So here's 1, 0, 1/3. There's a half. A third is about right there. That's the y-intercept. My x-intercept was 1/2, 0. Those are 2 points pretty close to each other. And then I have vertical asymptote of x equal negative 3/2. Negative 3/2 is negative 1.5. So right here, I'm going to draw my vertical asymptote. It's a vertical line, and these are going to be dashed lines. This is not part of the graph of my function, but they're just there for reference, right? So this is x equal negative 3/2. And then I have a horizontal asymptote of y equal 1. Horizontal line, right? Y equal negative 1 is the line passing through the y-axis right here. Again, this is going to be a dashed line. Okay. Now, to finish the graph then, what we do is, we could plot a bunch of points and that's fine. All I'm going to do is plot points beyond and between our vertical asymptote at negative 1.5 and our x-intercept at positive 1/2. Notice between the vertical asymptote and our x-intercept, I do have 1 point already, the y-intercept. I just need 1 point to the right of this. I need to find a point on the graph to the right of this. So for instance, I can plug in maybe at 2. What's the value of the function at 2? I plug in r of 2. Going back to the original function at the top of the page, right? I'm going to plug 2 in for x here and just see what I get as an output. And you can use the calculator to do this. So up top I get 1 minus 2, that's negative 1 minus 4, excuse me, 2 times 2 is 4. 1 minus 4 is negative 3. 4 plus 3 is 7. I get negative 3/7. Okay. So r of 2 is negative 3/7. So that's just shy of negative a half. So somewhere right down here I've got a point. Okay. And then and I can plot some more points. I can plug in 3, 4, 5, and 1, and 2.5 and 3.5. I can plot lots of points, but this is enough. I can also plot points in here, but again, just in between my vertical asymptote and my X-intercept and beyond it. So I need one more point, though, to the left of my vertical asymptote. So I'm going to plug in negative 3. What is r of negative 3? So I'm just going to plug that in. And up top I get 1, negative 2 times negative 3 is positive 6. 1 plus 6 is 7. And down here I get negative 6 plus 3. Negative 6 plus 3 is negative 3. I get 7 divided by negative 3, which is negative 7/3. Interesting, we got a little flip or reciprocal there, but that's just by coincidence. So negative 7/3 is negative 2 1/3. So if I go to the negative x equal negative 3, the y is negative 1, 2 1/3. So right about down here. Okay. Now again, this won't be a perfect sketch that I'm going to do. You can continue to plot more points and do this. But now I'm ready to go. So what do we know? From this point, which way does the graph go? Going this way. Do I go down? Do I just go straight this way? Do I go up? What happens? Well, can I go up and go this way? Well, if I go up and go this way, I've got to, first of all, I've got to pass through the horizontal asymptote. Can I do that? Can I pass through the horizontal asymptote? Does the graph touch or cross or touch the horizontal asymptote? No, I can't do that. And even that, I certainly can't go across the x-axis. Why? Because the only x-intercept we know is at 1/2, 0. So I can't go up. But what do I have to do? It's a horizontal asymptote. I do have to approach that. I got to get closer and closer to that. So I'm going to draw, it's getting closer and closer to that value. Now, again, this may not be accurate. It could be actually that it maybe does go straight a little bit or even down a little bit. I don't know. But eventually it's got to start going back and approach this. So as I plug in, way back here, I've got to get closer and closer to it. Negative 10, I've got to be real close to this horizontal line, y equal negative 1, but I never touch it. I get as close and close to it as I possibly can. Now, where do I go to the right from this point? Again, I can't go up because I can't cross the horizontal asymptote or the x-axis. I do know I'm approaching this vertical asymptote, and so I do have to either go to positive infinity, which I obviously can't do, or negative infinity. Well, the only way I have to go is down to negative infinity. I've got to approach this vertical asymptote this way. So I'm approaching a horizontal asymptote this way. As x gets closer and closer to negative 1.5, the value of the function is getting more and more negative, dropping down this way. It's the only way I have to go. Now, from this point, I'm approaching, going to the left, the vertical asymptote. Again, I've got to go up to positive or negative infinity. Well, I can't go to negative infinity because I will cross the horizontal asymptote and the x-axis, which I cannot do. So it's got to go up. It's got to be going up towards positive infinity. Okay. Now from this point to this point, what do? We just connect the points, right? Do we cross through the x-axis at this 1/2, at this x-intercept, or do we touch and turn around? Do we cross through or do we touch and turn around? Well, that's why we need this point. This point tells me I have to pass through. You say, well, can't I just touch and turn around and then come back down and then hit it? No, I can't hit the x-axis, only here. So this means I've got to go down, pass through, and go to that point. Now where do I continue this way? I cannot go above the x-axis. I can't cross the horizontal asymptote. I do have to continue to approach that horizontal asymptote, and I'll just draw it closer and closer that way. So there's the sketch of my graph. Now I know some of you know how to use your calculator to graph a function. I do not want you to simply plug in and evaluate, copy your graph. You could certainly now graph the function as you look at this example and check and confirm. But this is what I want you to do, to carefully sketch the graph. Okay. Let's do one more example real quick, a little last example. We went through that one kind of slow. We'll do this one a little bit quicker. So here we go to this function here. And I'm going to start off with this one. Unlike the last one, I want to go ahead and factor the numerator and denominator. The numerator here is the difference of squares. That factors as x plus 2 times x minus 2. The denominator factors as well. And again, you've got to be able to factor. Please be reviewing your factoring techniques, right? The last times the last is negative 12. They have to add up to negative 1 because the coefficient of x squared is 1. So what is that going to be? It's going to be negative 4 and positive 3. All right, now I'm ready for the domain. What's the domain? It's all real numbers, x, that make this a real number output. So obviously it's not going to be a real number output if x is 4 or negative 3, because I would be dividing by 0. So the domain is all real numbers x such that x is not equal to negative 3 or 4. What's the y-intercept? If I plug in 0 in, what am I going to get? I'm going to plug in 0 here. Notice if I plug in 0 up top, I get negative 4. If I plug in 0 on the bottom, I get negative 12. Negative divided by negative is positive, and 4/12 is 1/3. I think that was our y-intercept for the last function, just a coincidence. There's the y-intercept for this function. Find any x-intercepts. Well, that's where the numerator, right, is 0 and the denominator is not, when the function itself is 0. And the only way that's going to happen is if the top is 0. And where does that happen? That happens when is the top 0? When x is what? Plus or minus 2. Notice those are not either of our restricted values, and so those give us x-intercepts of negative 2, 0 and 2, 0. Find any vertical asymptotes. Well, again, these restricted values, if you notice, if I plug in negative 3, the denominator is obviously 0, but the top is not going to be 0. Negative 3 squared is 9. 9 minus 4 is 5. So I get this expression. This tells me I have a vertical asymptote at negative 3. S of 4. 4 squared is 16. 16 minus 4 is 12 divided by 0. Again, I don't get 0 divided by 0. So both of these are vertical asymptotes. X equal negative 3 and x equal 4. Remember, x equal for vertical lines, for vertical asymptotes. Does the graph have a horizontal asymptote? Well, again, notice the degree of the top and the bottom are the same. Degree of the top and the bottom are the same. And so, yes, we do. And it's at y equal what? The leading term coefficient of the top is 1. Leading term coefficient of the bottom is 1. So y equal 1 is our horizontal asymptote. Does the graph cross or touch its horizontal asymptote? Well, let's see. We want to look at this equation, s of x, right, equals to what? Its horizontal asymptote, y equals 1. Does the y value ever equal 1? Does s of x output ever equal 1? Multiply both sides by the denominator. 1 times the denominator is just this. And this time I can subtract x squared from both sides. Subtract x squared from both sides. And what am I going to be left with? Negative 4 equals negative x minus 12. If I add 12 to both sides, negative 4 plus 12 is 8 equals negative x. So what is x equal to? Negative 8. Right? So does the graph cross or touch its horizontal asymptote this time? Yes. And important, if so, at what point? So what's the point? What's the x and y coordinates for this point? The x coordinate we just found is negative 8. What's the y coordinate? Well, obviously 1, right? So it's on the actual horizontal asymptote. Okay, we can go to sketch the graph now. I'm going to plot the y-intercept, my two x-intercepts. I'm going to draw my vertical asymptote and horizontal asymptote. And then I'm also going to indicate the point right on the horizontal asymptote that I have, negative 8, 1. So the y-intercept was 0, 1/3 again, so 0, 1/3. It's about right there. My x-intercepts were negative 2, 0, and 2, 0. Now I have two vertical asymptotes, right? Two vertical asymptotes, x equal negative 3 and x equal 4. So x equal negative 3 is a vertical line, right? Passing through x equal negative 3. And then x equal 4 was the other one. Horizontal asymptote was y equal 1. And then last but not least, don't forget, before we finish it out, that we do pass through or touch the horizontal asymptote at negative 8, 1. Okay? So let's continue to fill in missing pieces, so to speak, if we need to. Notice I think I pretty much have everything except over here. If I look at the values less than negative 3, I have a point right here on the horizontal asymptote, but it might be a good idea to plot another point somewhere in there as well. So I'm going to use the calculator to help us plot some points. I'm going to go to y equal and just enter in this function again real quick. X squared minus 4 divided by x squared minus x minus 12. Okay. Delete these entries here. Okay. So let's just see what we have for, let's try negative 6. The output is 1.0667. So at negative 6, we're 1. Here's 1.0667. So we're just above, slightly above, right? Okay. And I can plot some more points, negative 7, negative 5, and so on. But I'm going to continue to do that. I'll go to negative 8. I probably should have expanded it out a little bit. Let me see what's happening at, say, negative 10. Negative 10, notice we're less than 1. So that means, obviously, back here, we're going to cross through that horizontal asymptote. So by the time you get here's negative 9, negative 10 is going to be a little bit less. Let me extend that horizontal asymptote a little bit longer. Okay, so by the time we get to negative 10, we're a little bit below, and we'll talk about how that will help. Now, between negative 3 and negative 2, we can plug in a point there. Let's plug in negative 2.5. Negative 2.5, the output is negative 0.69 or negative 0.7. So we're down here about right there. Okay. Between these two x-intercepts, we've got our y-intercept. Between this x-intercept and the vertical asymptote, I can pick 3. And at 3, we're negative 0.84. something, so we'll plot that point down there. And then let me pick a point in here. Let's try 6. If I plug in 6, the output is 1.7778. So 1.78, about somewhere right around here. Okay. Now again, you can plot more points if you want, but this is really sufficient. I mean, if we come over here, let's start from the right and work our way left. Where do we move to the right here? I've got to approach this horizontal asymptote. Can I cross it or touch it? No, because the only place I touch it is right there. So I'm just going to approach the horizontal asymptote from above. Right? Going this way, I've got a vertical asymptote. I can either go to minus infinity or positive infinity. I cannot go to minus infinity because I can't cross or touch the horizontal asymptote or the x-axis. So I'm going to go towards positive infinity this way. Okay. From this point, approaching the vertical asymptote, I either go up or down. The only way I can go is down. Right? Because I can't cross again the x-axis or the horizontal asymptote. Going this way, it's kind of like just connect the dots, right? You can see how it's going to curve through here, and then when I get to this point, where am I going to have to go? Towards negative infinity again. I cannot go up and cross, and so I'm just going to draw it this way, I guess. So that's getting closer and closer, almost merging, it looks like, but it actually never touches that vertical asymptote there. And then over here, from this point moving to the right, obviously, I cannot cross again the horizontal asymptote, only here, and so I've got to go up to positive infinity this way. This way I'm going to go, of course, to this point, and then as we said, we're going to cross through because we're down below here. Now where do we go here? Do we continue to go down? No. What must happen is what? We might go down a little bit more, but we're going to eventually approach again. We have to approach this horizontal asymptote from below this time. So that was a little tricky in that. Again, this is a rough sketch. I might not have, the height of the function exactly right. If you plot more points, you can be more precise. But that's a rough sketch of the graph. And that's what I'd like you to be able to do on a test, is to go through each of these parts that we went through and then carefully sketch the graph showing vertical and horizontal asymptotes. Okay. All right. Well, that's all for this video.